Hey Ashley, when how I like to think about these is just as a series of transformations, right? So that's where we take some base function, we add and subtract numbers, and it does different things depending on where that number is in the equation. So what I put in here in the Desmos, and I can share this link with you so you can play too, I just put in y equals ab to the exponent x plus c, and I'm just calling these a, b, and c because that allows me to slide and pick values here. So right now a is 1, let's just forget about that for now, and B is 1, C is 0 for now, okay? So that's what we have. Now check out what happens to the graph, and you can literally just see it's flat right now. But as I increase the base, sorry, Control Z, there we go. B is, I'll just say 1 for now. Let me increase that base now so you can see, hopefully, in projector mode, make it a little better for you. There we go. So we can see now that as the base increases, the steepness of that line, see how that just cranks right up? And if I play that, and it'll just modulate between 10 and negative 10, watch what happens. Now there's no values when the base is negative. Negative base doesn't really do much for us, but we can see kind of a quick jump right there. So as the base decreases, it gets a little less steep, until we hit 1. And 1 is a flat line because 1 to any exponent is just really going to give us 1 anyway, right? But as I get negative, so not even negative, as I get less than 1, so a decimal or a fraction, so if we have something like that, the exponential function flips around, and now it's descending as we read left to right. And again, once it hits 0, it's totally just gone, right? Like it's just a flat line because that's all we have here. Negatives don't really matter here, like a negative base raised to an exponent, it's not really going to give us any real answers here. So that's really what's happening with the base. So when you think about this, just take a look at the base. I know in the question you were looking at right here, 2 to the exponent x minus 3. So we have a base 2, right? So I should see some sort of basic, like, increasing as we go left to right. So that's the first thing we should know, right? Their second transformation, sorry, let me put this back to 1 right quick. And I'll erase all these in my... Okay, let's play with C now. So right now C is 0, so we just have an X up here. But as we add, let me put like a legit, like we'll do 2, so we have something we can look at. Watch what happens as I increase C. So this whole function is now moving left to right. And that's known as a horizontal shift. If you think back to Math 1046, we did all kinds of that stuff. Now we're just applying the same ideas to exponential functions. Okay? The big kicker here is that it goes in the opposite direction, like all horizontal shifts. So right now, C is minus 9.5, so this would be like x minus 9.5, and we can see this thing is moving to the right. And as I increase that value, it moves to the left. So it kind of goes in the opposite direction as to what I would think it is, right? If it's positive, it shifts to the left. If it's negative, it shifts to the right. So again, whenever you add or subtract numbers up in the exponent, that's a horizontal shift, all right? Now check out the value. And just put this back to, I don't know, I'll do 1 or something right now. Check out what happens when we multiply this whole thing by some other number. So look what happens when I multiply something by a. Right? Now that can really impact it, right? Because see what happens if a is a negative number, then the whole thing becomes negative and it'll flip downward like that really oddly. So that's a thing, commonly a would be like a -1 type situation. As we increase it again, it even more, like it forces that slope gets really, really, really steep by increasing that value. Okay, so those are just some features. I can add one more value here, d, and I'll add a slider for that. And d is basically going to be our horizontal shift. Okay, so let me just return all this stuff back. Right now we basically have 2 to the x, right? C is going to be 0, we have 2 to the x, that's it. Now if I increase values here, or I just play this, watch what happens. Sorry, I'm playing C, wrong number. Let's make C 0, let's play D. So we can see now D, because this number out here, this is the vertical shift, so we're shifting the whole function, or all values of the function, up or down. So that's a thing as well. Okay, so keep all of this in mind when you start to do your homework, because now, once we go in to do our homework, I can look at any function now. Okay, we have 2 to the x minus 3. I'm going to expect to see 2 to the x, which again is like a general positive curve somewhere, and it's going to be shifted 3 units to the right. That's all. That's all that's going on here. Now, physically how to graph that, that's a bit of a different pickle, which I might show you in a sec. I can show you how to actually use the graphing tool now if you want. So just bear with me and I'll load one up for you. All right, Ash, so I just pulled up one in kind of my homework, if you will. In this example, we have to graph 4x plus 1. So here's what we're going to do. We're going to graph it all with the asymptote. I'm going to click my little button here to enlarge the graph. Now what we're going to use is the exponential tool, which is right here. We're going to click that, and you can just click anywhere, and it'll basically just drive in a basic function right there. It doesn't really matter where you click, and we're going to do all of our transformations right here. First things first, always check to make sure we have the right base in. It should, but always double check. Sometimes they put like 0 or 10 or something weird. We have the right base, so that's cool. And we also have a horizontal shift, right? This has gone 1 unit to the right, to the left, sorry. Okay, so we got to go over here to our horizontal shift, and this is going to be 1. Okay, so let's graph that up. And you can see a +1, but look, that put it in the wrong direction. So I'm going to make that a -1 because it always goes in the opposite direction. Other than that, we have the right base. We have the right horizontal shift right here. We could reflect this if we needed to over the x or the y. If we had a stretch or a shrink, some other number being multiplied by 4, we could do that. But again, I think we're pretty good there. So we can graph that. Now what I forgot to do, let me click this graph again. Once we're happy with our exponential function, we can see clearly from the graph, this has a vertical asymptote at y equal to 0, right? Right there, the x-axis. So what I'm going to do now, I'm going to click my straight line tool right here. I'm going to make that a dashed line using this option, and then just anywhere along this axis, so you can click once and rotate it around. Just click anywhere along there, and that will put in a dashed line to indicate that's where the asymptote is. And the dash matters because it means there is no value there. On a test, if you got that wrong, let me know. I definitely give you points for that, but you know, I might as well teach you the right way. We'll check our answers and we're good to go.